Okay, today we're going to learn about tangent lines. First, we want you to be able to learn to use the relationship between a radius and a tangent. And then we also want you to be able to use the relationship between two tangents from one point. So let's start off with some definitions. First of all, we want to talk about what a tangent line is. A tangent line is a line in the plane of a circle, so we're talking two-dimensional objects here, that intersects the circle in exactly one point. So if we're looking at this, here we can see we have our circle, we have a line, and it intersects it in one point here, and that point is called our point of tangency. Okay, so that's our second definition. The point of tangency is the point where a circle and a tangent line intersect. Okay, so we can see we've got a tangent line, a circle, and a point of tangency. Okay, if a line intersects a circle at more than one point, it cannot be called a tangent line. It has a different definition, and we'll talk about that later in the chapter. Let's now talk about Theorem 11-1. This theorem says if a line is tangent to a circle, and so here we have our line and our circle, then the line is perpendicular to the radius drawn to the point of tangency. So what this means is if we have our center of our circle and we have a radius drawn that intersects the point of the tangent line at the point of tangency, then that radius is perpendicular to our tangent line. Okay? That's a very important concept that you'll see repeated throughout mathematics, and we'll expand on it when you get to calculus. So we can use this theorem to solve different problems involving tangents to circles. So let's look at this first problem. With this problem, we have a circle, we have a tangent line, and we have a diameter. Okay, so this diameter intersects our tangent line. Now, we know from Theorem 11-1 it's going to intersect it at 90-degree angles, which gives me a right triangle. Now, we have 180 degrees of interior angles in any triangle, so 180 minus 90 gives us 90 to spare for these other two angles, right? One of those is 72. What's the other one? Well, that would be 90 minus 72, so that would be 18 degrees. Looking at our second problem here we have two tangent lines, and we can see that they're going to intersect at 90 degrees, right? And we've got this angle here, which is 100 degrees, and we want to know what this one over here is. Well, what we can do is add up all these interior angles because we don't know anything more about this, but we know we've got a quadrilateral, and that has 360 degrees of interior angles, right? So we've got 90 plus another 90 plus 100 plus some other angle should all add up to 360 degrees. So subtracting everything away, we get x should equal 80 degrees. Okay? So adding that back up, 90 plus 100 plus 80 does give us 360 degrees. So we know that this angle here is 80 degrees. Okay? Let's talk about Theorem 11-2. This theorem says if a line in the plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle. And if we think about this, this is the converse of Theorem 11-1. Theorem 11-1 starts off with a line tangent to a circle and says if you've got a line that's tangent to a circle, then it's perpendicular to that radius. Here we've got if the line is perpendicular to the radius, then we know it's tangent. Okay? So this works both ways. It's biconditional. And we can use that with other problems as well. Next, we have Theorem 11-3. Theorem 11-3 says, if we have two segments tangent to a circle from a point outside the circle, so we've got a common point out here outside the circle, and we've got two tangent lines meeting here and here, right? Then the segments that connect those tangent lines, the segments that form those tangent lines, are congruent. Okay? So it's kind of like it's kind of like a clown hat thing, right? We know that the sides of a clown hat are going to be congruent type thing. But that's a three-dimensional thing, and this is two-dimensional, so I'm digressing and I'll stop. But in a two-dimensional world, any circle where you have two tangent lines connecting with the circle and a point outside the circle, those segments are going to be congruent. So what we've learned what a tangent line is. We've learned the concept that tangent lines to a circle are perpendicular to that circle's radius at the point of tangency. We've also learned that the converse of this is true. If you've got a line perpendicular to a radius at its endpoint, then it is a tangent line. And we've also learned that two segments tangent to a circle from a common point outside that circle are also congruent. And we'll do more problems like this with these theorems in class and in your book work and things. Okay? That's it for today.